This video we're going to talk about the stem and leaf plot. So stem and leaf plot, each number is separated into a stem and a leaf. The leaf is the rightmost digit. Okay, so if you think about a number like 4576, so 4,576. So the stem would be this first part, and then the leaf would be the most right digit, which happens to be 6. So this right here is the leaf. So how would we write this? We would write this as 4, 5, 7, and then we put a vertical line here, and then a 6, okay? So the leaf is on the right side, and that's the only thing that's on the right side, okay? So there should always be as many leaves as there are entries of data points. So since we just had one number, there's one leaf, okay? So the advantage to this is that when you graph this, you can still see the original data, and so it's easy to sort the data. So let's take a data set. So we've got our data set here, this data set, and what I'm going to do is I'm going to create a stem and leaf plot. So first thing I'm going to do is I'm going to draw a vertical bar, okay? And then I look and I say, okay, I've got a single digit, I go into the tens, and then I go into the 20s, and then I go into the 30s, and then I go into the 40s, and then I have the 60s, and I've got the hundreds, and then I guess the 110s, okay? So how would I write a number where it's just a single digit like 5? Because the most left and the most right, well, there's no numbers over here, right? But you can write a number like this where it's 0, 5, that's equal to 5, right? So that would mean the most right digit is 5, so that's the leaf, and then the stem would just be 0, okay? Now that's our only single digit, so we're good with that. Now for 11, how do I write 11? Well, the most right digit is 1, okay? And then the stem is 1, all right? So since the stem is not 0, we got to go down to the next row. And so I'll put a number there. So this row right here will be all my tens, like from between 10 and 19. So 11 here. To write 13, all I do is, well, 13, most right digit is 3, so that's 1 and then slash 3, so we're still on the 1 row. And so I'm going to put a 3 here for the 13. 18, I'm going to put an 8 there for that. So what you notice is this. You see there's 1, 2, 3 data points on this row, so there's 1, 2, 3 leaves. So the number of leaves represents the number of data points in that category, okay? So that represents that row. Now we go into the 20s. So to get 20, I start with my 2s, and then I go 0 for 20, 2 for 22, 2 for 22 again, and then 4 for the 24. And then I got to go to the next row for 31. And then I do 33, 1, 2, 3 times. And then I have 34, 36. Okay. Then what do I have? Well, I got to go to the next row of 40. So 4, and I put a 0 here. And I have a 9. And now it might be tempting to write a 6 here, but then you would be skipping some points. So this is where people might mess up. They skip. And so we put a 5 there to represent the 50s, but guess what? There's nothing between 49 and 61, so we leave the leaf side blank, okay? And so then I jump down to 61 to get 61, and then I don't have a 70 or anything like that, so I'm going to have to keep stretching this thing downward. All right, so that's 7, 8, 9. Looks like I'm going to have to go to 10, because look, 101, the most right digit is 1, so that's 10, and then I split up and I put the 1 on the other side. 115, it looks like it's 11, and then the 5, so I have to do 11, and then the 5, and then 11, and then the 18 for the 118. Okay, so this is the stem and leaf plot. All right, for that data, for that first data set there. So it kind of gives you an idea. Looks like your data set mound has most of the data centered over here, and then we have a few outliers way over here. Okay, and so the advantage to the stem and leaf versus the frequency histogram is that you can actually look at the stem and leaf and say, oh, there was a data point of 18 right here. Whereas with the frequency distribution, it just tells you, okay, in the class from 10 to 19, there were 3 data points. Okay, so with the frequency distribution, it just tells you how many there are, 1, 2, 3. It doesn't tell you what they are like the stem and leaf does. Okay, so that's the advantage that you have to the stem and leaf. Now, if you got this down, great. Okay, so you might run into a homework problem where they do a stem and leaf with 2 rows. Okay, so unless they tell you to do one with 2 rows, then this is what they're talking about when they ask you to do the stem and leaf. Okay, so this is kind of your default one. Let's do one where it's a 2-row one. Now the 2-row one would pop up if I have a data set where most of the points are centered around some smaller range. Okay, so this is the 2-row stem and leaf. Okay, excuse me, plot. So how does the 2-row work? Well, I'm going to split it up to where the first row are the ones that end in 0, 1, 2, 3, and 4. And then the second row are the digits that end in 5, 6, 7, 8, and 9. Okay? So ending digit is split up this way right here. All right? So how do I do it? Well, I'm going to first draw my vertical line, and then I'm going to have 0, 0 instead of just 1, 0 like I did here, where I put all my single digit numbers on this row. I'm going to have 2, okay? Or I put, you know, the numbers from 0 through 4 on the first one, and the numbers from 5 through 9 on the second one, okay? And then I'm going to do 1, 1, and then I'm going to do 2, 2. And I think I can stop there because my biggest number is 27. So 1 falls on the first, 3 falls on the first, 5 actually falls on the next row, 7 and 8. Now 10 is going to be 1 on that side, 0 on that side. 12 is here. 21 is going to be down here. 23, 24, and then we have 25, 26, 27. Okay? So that shows you how to do a double. All right, so this is the key right here for your 2 stem row. All right, guys, hopefully that was helpful.